What is going on, everybody? Welcome back to another video for Cup of Code. Back to 100 days of Python. I'm going to start towards the end of this to start getting into NumPy. I know I'm talking about the ending of like video 20, but getting into utilizing NumPy, utilizing functions more, and then starting to really play with matrices, different vector arrays, scikit-learn, so we can start to mold ourselves into this machine learning mentality, deep learning, artificial intelligence mentality. Because quite frankly, I personally and professionally have no desire in terms of web design. So I'm not going to spend any of my time on that because I can't do both things at once. I have my day job as it is, and then making these videos on top of it is another piece of the puzzle. And again, I'm doing this more. It's great that you guys get to capitalize on this, but again, this is mostly for people who are trying to learn, and primarily as a legacy piece I can leave for my two boys, so they can go and they can learn programming the way that Dad learned it. So with that being said, let us jump right in. So today we're going to start off going through some functions. So a function, as you've seen in Python, you can call up functions depending on the library. And then we do open and close parentheses when we're letting the Python know we're calling it a function. But essentially what it is, a function is you're telling Python, this is what I'm calling it, these are the arguments I'm going to give it, and this is what I want you to do with it, and this is what I want you to tell me back. So we can create our own functions. Many times there are functions that are already in play. Other times we want to create our own. So that one's actually going to be too difficult to start with. So let's do something a little bit simpler. So the first one here has function to sum all the numbers in a list. So we go, all right. And again, I'm going to, like we always do, run my debug, I mean. Nope, I'm in functions, yes. So, all right, I want my console. I'm actually going to bring this down. I'm going to free this up so that I can keep the screen a little bit more maximized for you guys. So I'm going to do floating mode so that I can kind of bring it in and out of frame when we need to see what's going on. So, boom, define some of the numbers. Something you need to know about functions is I haven't hit F8 yet. When I do hit F8, it is going to, oh, look at that. I'd already ran that first piece of code. Cheater. Oh, I hate when code cheats. Yeah, all right, we'll ignore this. That's actually going to be the answer for the first part, but if you can't figure it out just by looking at it, we got a bigger problem, but we'll go from there. So, defining, when we have a definition, when we're defining a function, Python's going to skip it because we haven't given it any arguments yet. And what I mean by that, I just want to quickly go through a basic construction of a function, defining a function. So the def is just telling Python we're going to define a function at this moment. I've named it. You can name it whatever you want. I'm naming it SumIt. Just don't ever name it starting with a number. Python's very particular about two particular pieces anytime you're trying to name something. Whether it's a variable or a function, doesn't matter, but avoid starting with a number, starting with an integer. So one of the functions I did was for, I think it was in NumPy. Let me look real quick. We're actually going to do this in the next video. Yeah, for dimensions. I was when I did this 1D, I actually did it with as the number. Oh, why did it freeze on me? I actually did it as the number 1, and it was a pain in the tuchus. I gotta email them. Ever since Anaconda did an update yesterday, and now PyCharm is being a pain in the butt. So what I might do is move over to Spider. Let's see if we're gonna do that. Let me see. Yeah, why are you being so funny? Funny bunny. All right, I'm going to pause this, and we're going to come back into Spider. All right, just picking up where we left off. I'm going to give PyCharm one more chance. It's updating the skeleton, and maybe because I was running the debugger on a different script and then jumped over to a new script. I don't know. Maybe somehow with the console got confused. But we'll give it one more shot, and then otherwise we'll show you guys Spider for the next video anyway. So again, back on PyCharm, when naming variables, naming functions, you never want to start with an integer. If I try to do that, it's going to give me a syntax error. So I had to name it 1. Also, you never want to start with you don't want to start with a reserved word in Python. So you don't want to ever start it with for, because then it's going to be thinking it's looking for for. Or this would give me a syntax error because we have for loops. It's a reserved word. So you always want to avoid that. So let me go back to our sum of all numbers in a list. Let's run through these functions. So we're going to do this one first. Let me bring this down just a tad. Function to sum all the numbers in a list. So I said we're defining a function. We're naming it sum underscore it because we're going to sum it. And then in parentheses here, all functions have parentheses. We're putting the argument. So an argument for a function is we're just telling Python, these are the inputs I'm going to give you. Now, I wrote the word numbers, but it doesn't know that it's going to actually be integers. But it knows that there's going to be an argument expecting numbers. So at some point in the code, I'm going to say what numbers means so that it knows what the hell I'm talking about. But this could be as many arguments as we need. If you go back to our argv video, I think about 2 videos ago, we're using passing things through terminal. It would use the word arguments. It would say, oh no, I was expecting 4 arguments, you only gave me 3. And that was talking about a function that was defined. It's saying for argv function, they have 4 different parameters inside these parentheses, 4 different arguments that the function is expecting. And if it doesn't have it, it can't run because it uses those arguments within its code. And then when we're going to actually do something with the function we create, we have to pass what that argument is going to be. Now, even though I only have numbers as my argument, I can pass as many numbers as I want because, again, this is a summing. You'll see it makes sense in the code. So we always have to end with a colon, and then I'm doing start equals 0. So I'm just telling it, I'm creating a counter. This could have been count, it could have been sum, it could have been total, I don't care. You could have wrote pumpkin equals 0. Can you tell I'm on Halloween mode with the orange? So start equals 0. For num in numbers, this could have been for x in numbers, could have been for I in numbers, doesn't matter. But I put for num in numbers, so I'm telling it for this loop, this for loop, for num in numbers. So all the elements that are in this argument, for every element that's in this argument, because again it's an argument because we're passing it through our function that we're defining. What do I want you to do? For number in numbers, start plus equals num. So this really looks like if we were going to say, what does that mean? That is start equals start plus whatever the number is in the list. So what is our start? Our start is 0, and we're doing addition, so 0 is safe. So when I do for num in numbers, so when I go through this, it'll make more sense, but I'm going to keep this here for now just so you can see that. But you can always, it's just redundancy. You don't have to write start again when you had your variable. You can just do plus equals, minus equals, times equals, which we'll see a couple of those. So what it's going to do, it's going to take our starting number here, and it's going to add whatever number we're at in our numbers argument. And then it's going to go to the next line, return start. Give me what that number is. Tell me what that number is. So it's going to keep running this loop until all of those numbers are expired. So we're going to debug this now using this argument. So I'm saying print sum underscore it. So it's going to reference back to the defined function we created, sum. It knows it's expecting an argument, and in that argument, I'm passing all of these numbers. Now you'll notice we have parentheses for the print function. I have parentheses for the sum function, and then I have parentheses just for the argument because there's multiple variables. If it was only one argument, I would not have needed these extra sorts of parentheses. But again, if I only put one number, I wouldn't have been able to do anything because it would have got stuck. It would have given me a syntax error. Iteration problem. So what is this going to do? When we run sum, it's going to say, all right, for this function, I have this argument. So I'm starting at 0. For num in numbers. So for num, 4 is a num in numbers. It's an item. 5 is an item in numbers. 6 is an item in numbers. 7 is, all these are items in numbers. So for num in numbers, so the first one's going to be 4. Start equals, so we're changing the count number. Start equals start, 0 plus 4, return start, 4. But we're not going to return start yet because we're still in this loop. So we're going to make more sense when we debug it. So let's actually do it. So I'm going to, I don't need to do that. I just need to do this. I need to do this. And let's see if we can screw everything up again. I'm in functions. And I want to make this a floating window so that it's easier to see everything. So, oh cool, I'll put it like this. So I'm going to F8 through. So you'll notice it went from def sum, it went from the define the function all the way down to print num, because again, it doesn't execute this. It doesn't know what the hell we're executing because we didn't give it an argument yet. So now we're giving it an argument, so now it can jump back up. So it tells me it's a class tuple, meaning that it's going to be immutable. And in that tuple here is our numbers. Here's our argument. That's why I want you to think of it. And I did want you to notice I have a float here and I have integers. So we now have our numbers argument. Start equals 0. So I'm going to go to the next F8 again. So now we have our variable start equals 0. For num in numbers, what's the first number? 4. I can actually get rid of this a little bit. So we did 4. So look, it did start 4, puts it in its memory. But we're not done. There's still more numbers. What's the next number? 5. Now it went to 9. See how it went to 9 there? Because when it got to 5, it did start equals start. Start was 4 at the time plus 5. So now 9. So now we're going again. It's going to be 6. And it's going to, as we go through this, these two lines here, it's going to keep doing these two lines in this for loop, going through all these iterations on the items in the argument. And it's going to keep adding them. It's going to keep changing this start based on this mathematical formula that we put in. It's going to do that until we get to the end. So now it did 12. Now it's doing 6.7. We're doing 10. 10 is the last number. So what happens is when I come up here, for num in numbers, 10 was the last one. It's done. So it's going to jump down to return start. Return start is 58.7. So that's what we're going to get when I F8 through it, 58.7. So now it returned the end product of that function that we defined. So let's move on to the next one. Function to multiply all of the numbers in a list. So I'm going to, do I need to restart or can I just, okay, I can just F8 through it, sweet. So you notice again, I started on defining the multiply function. Our argument is numbers. Starting at 1, why are we starting at 1? Very simple mathematical function in the sense that if we multiply anything times 0, we're going to get 0. So this is multiplication, so we got to start at 1. For num in numbers, same thing. Start equals start plus num, same exact thing. We're totaling up. We're multiplying all of the numbers together, and we want to return that final number. So we're going to return start. So this is again acting as a counter. The only difference is our operation. Before it was addition, now it is multiplication. So it's going to be start equals start times whatever the number is in our list. So I only have 2 numbers here in our argument. So I'm going to FA through that. And we're going to create again a class of a tuple, 3, 7. Start is going to be 1. So it's going to create that variable for a number. For the first number is 3. So start is 1. So 1 times 3 is 3. So start should change to 3 when I go to the next level, and it does. Number is now going to change into 7, which it does. And now I have start equals start, which is 3 times 7. So now start should move to 21, which it does. There are no more num in numbers, so it should jump down to return start, which it does. Goes down, print, and again, multiply 3, 7, so I should get 21 in my output window. When we go, there we go, beautiful. So this also could have been as many numbers as you needed it to be. You also could have done floats. If you wanted to do floats and return an integer, you can just put a comma int to return an integer. You can also have that part defined in your function if you so choose. But the main thing I want you to get away with is defining, we're naming a function, we're telling it what we want the operation to do, and then we're saying we're returning that function by calling it. We're calling the function, that's what this is. So print calling the multiply function, and these are the arguments that we're passing through it, and that's how we know what arguments we need to pass through it in order to not get an error. So here, this is a function to reverse a string. I think this one is, let's see, one's more complicated. Probably the last one, first one that's on there. So we'll do this one next. So we are now going to, boop, we're creating a function to reverse a string. I'm actually going to bring this up like this. Oh, darn it. Sorry, guys. Stop it. Awesome. So we're going to start in this first line here. And again, as you know, because you're an expert now in functions, it doesn't run this. This is just defining a function. It's going to jump down until the function's called. And the function's called down here in this print function. We're calling multiply, so it's going to jump to multiply. Stupid. Let me get rid of that. We're defining the function back it up. And back it up where the argument is going to be a string. So again, as I was saying before with multiply, the function is not going to actually execute this code until we call the function. So when we call back it up and we're passing an argument, we're passing love it, Now it's going to run through the actual code. So we should see it go from def down to print and then back up in. So let's run through this and see what it's doing. So I'm going to F8 through. So it's calling up the string that I put in. The function, when we called the function back it up, the string I passed was love it. So in memory, it's storing string is love it. And the reason it's saying string is not because it's a string, it's because that's what I call the argument here. So now we have a variable x. X equals an empty string. Nothing fancy about it. So we're going to F8 through it. So the computer should give me an empty string, which it does. Now I have count equals the length of the string. So I want my count, which is just a variable we created. It's an object. The object count is going to create the length of the string. So the length of the string is how many actual values that we have. So if we count this, we know we're going to get 1, 2, 3, 4, 5, 6, 7. This space actually counts as a length. So we should get a 7. So we have a count of 7. Excellent. Now what this while loop is saying, while the count is greater than 0, so true, we can move inside the loop, x equals x plus string count minus 1. So let's talk about what this means. So x equals, we're doing it, it's an addition. So x equals x. So x is right now is empty, right? So x is empty. X equals x, so empty, plus string count minus 1. So string is love it, but we're saying the count 7, we're indexing it. 7 minus 1 is going to be 6. So whatever is in position 6, that's what we're calling here. So it's going to be x plus 6. So I don't know if that makes sense, but let's run through it and we'll see if it makes sense to you. So I'm going to F8 through that. So that was true. So this is true. So then we're saying count equals count minus 1. Before we get to this part, I want you to see it pulled the t. So how did it do that? Well, again, this really translates out into x equals x plus, for this one, it was string, and it ended up being 7 minus 1 was going to be 6. So we're saying an index position of 6. I want you to pull that off. And that's why we did minus 1, just because it's indexing. Indexing starts at 0, and our length was counting straight up numbers. So what it did here, I was going to say, why the hell did I lose that? What it did here was, when it got down to this part, x equals x, x was an empty list. So empty list plus string, the string is love it, index position number 6. So 0, 1, 2, 3, 4, 5, 6. It pulls it. I'm saying I want x to now equal. I want x to equal whatever x was before, which right now is nothing, plus I want x to equal the index position 6 of the string love it that I have. And that was met, so then count became minus 1, which was 7. 7 minus 1 is 6. So now we can still stay within this while loop because the count's greater than 0. So let's run through it. Let's keep going. So now we're running through. It's saying x equals x plus string of index 5, because now we're running through it. Now it's 6 minus 1. So now that's switching to 5 when we run through this. And at 5 position, see how it put the I? First it went t, then it put the I because it was indexing the position. Now the count here from 6 is going to turn to 5. And since we're still above 0, we're still within this while loop. Now I'm going to go down to the next line. What's in position 5? Well, it's going to be an empty space, right? So now we're appending our list. We're saying x equals x, which is it, and then, ti, and then we're going to add a space because now we're actually in index position 4. 6, 5, 4. So empty space, it did it, changed the count to 4. 4 is greater than 0, true, so we're going to go through. Now we're going to be indexing position 3, 0, 1, 2, 3. So now we should pull out the E, which we did. Count's now going to go down to 3. And we're going to keep doing this until we get down. Count 1 is greater than 0, so that's going to go. It pulled out the L. Now we're count of 0, because 1 minus 1 was 0. That was our index position. 0 was the L. While count is greater than 0, count ain't greater than 0 anymore. So what's going to happen? We jump out of this while loop, and we go down into the return. Return x. X started out as an empty list. Now x is the reverse of the string that we passed through the argument that we created. Back it up. So I'm going to F8 through that, and it's now it can execute the print function, and we print out tvol. So you can make your own damn language if you choose. So this was just reversing a string. There absolutely are other ways you could have done it. You could have just simply taken the string. We could have done a reverse function that already exists within different libraries to reverse it. I could have simply had an empty list and I could have indexed it from start to finish -1 if I wanted to. Meaning, you could have x, oh wait, where did we go? If you wanted, you could have had x equals an empty list, and then you could have did a function that takes the previous string and does from the beginning to the end -1, which I think we're going to see that when we do NumPy. And what this is saying, you're saying take from the beginning of the string to the end of the string and then index backwards by 1. So there's a number of different ways you can skin a cat, as they say. But this is also not the smartest way to do any of these function pieces, because these are computationally intensive. Function loops are computationally expensive, which when we get into deep learning work, you'll see there's other ways around it. But I want you to first just understand what the hell we're even doing. So now we can come back to the very first function, which I think is one of the more complicated ones, just to get your mind around. So let's knock that guy out. So, and we can already see the answer we have is 6. But again, when you go through this, you won't even need the function to know it. You'll know it, but this is how we have the computer do it. So we want to make a function that can find the maximum of 3 different numbers. And we're going to pass those numbers in. So what I did, this is actually 2 functions because we're comparing 3 numbers. So first we're going to compare 2 numbers, get the maximum value of that, and then compare that value to our 3rd number. And there's just one part of it that may not seem intuitive to you, and that's why we're going to do this. So all I want to show, so we're defining max of 2. So first we're going to have a function called max of 2, which is going to take 2 arguments, an x and a y, just 2 variables. And with that, what are we going to do? If x is greater than y, so if x is greater than y, return x. Makes sense, right? If 6 is greater than y, give me 6 back. Otherwise, return y. So if it's 3, 4, then nope. Is 3 greater than 4? No. So then return 4. Awesome. Next function, max of 3, x, y, and z. Now we have 3 arguments within our function called max of 3. Return max of 2. So again, now we're saying return this function, max of 2. But the arguments we're passing, we're going to actually pass a function into an argument. So what do I mean by that? So we have 3 arguments in this function, right? This function, what is it returning? It's returning the function max of 2. And max of 2 needs how many arguments? 2 arguments. Well, the first argument for max of 2 is going to be x. The second argument for max of 2, this y argument here, is going to be the result of that function already running. So that's why timing can seem a little counterintuitive here. So we can't run max of 3 function until max of 2 has been run on variables for the arguments y, z. After it does this max of 2 function on y and z, which is kind of like saying x and y of this function, and it has that value, that return, then it can take that return value, plug it here, and then we're giving it a new x for the max of 3 and saying return this output with that x and compare them. Let's see if it makes sense as we debug it. And then we have our print function. We're calling the max of 3 function, because that's what we want. We want the max of 3. And we're passing 3 arguments, 3, 6, -5. Now that's going to be in that order. So now that means that we have x, y, and z. All right. So let's start up here and let's F8 through this and see where we end up. And debug, why are you being a pain in the ass? Thank you. Okay, cleared out the screen for the console. F8, let me go back to the console just so we have it there. So as you can see, we skipped def of 2 because we haven't even gotten to calling the arguments yet. So now we're down to def max of 3. It's going to skip that and go to the print. So now that we're in the print function, we're calling the function max of 3 and we're giving 3 different arguments for it. So where do we go? Well, we go max of 2. Why did we go max of 2? And you may be asking yourself, why the hell is it pulling 6 and -5? That was y and z, right? Well, this is what I meant before by for max of 2, it's going to pull x and y. This x and y is from this function, max of 3, x, y, and z, 3 arguments, right? Let me rephrase it a little bit. If you went from max of 3, 3, 6, and 5, you gave 3 arguments. It's not going to go to max of 2 because we're calling max of 3. So what the computer did in looks like one step is not one step. What it really did was this. Max of 3, so it goes, okay, you want me to be here. I'm here. I need 3 arguments. We gave it 3, 6, -5. X, Y, Z. It goes, all right, sweet. Next line. Return max of 2. Okay, what do I need for max of 2? That's a function. I need an x, and I need a y. We have 3 arguments. So it says x, all right, we got a number 3. That's a number 3. And then for the second argument, it's max of 2, y, z. So max of 2 means run this function on y and z. Well, that's 6 and negative 5. So we have 6 and negative 5. And it's just remapping them as xy because that's what the arguments we're passing through for the man of 2 function. So now what it's going to do is it's going to run max of 2 for 6 and 5. So let's F8 through this. So now it has those in memory. If x is greater than y, 6 is greater than negative 5, true, return x. So now x is going to be returned. So I don't want you to get confused because x is 3. You're going to say, what the hell, x should be 6. We returned the value that was sitting in variable x. We returned the value of x from this function, which was 6. And that's what's being plugged into memory in here. Man of 2, 6, negative 5, 6 was the winner. So now what can happen is now max of 3 can run, and it's going to compare 3 and 6. And it's going to see which one's going to run. So now we have 3 and 6. Run max of 2, and the arguments I'm giving you are 3 and 6. If 3 is greater than y, is 3 greater than 6? No. So return y, return 6. Finished it. So return max of 2, which we did that, and the arguments were 3 and 6. So it's going to print out a 6. Now maybe you can see why I said this was one of the more complicated ones. It's not difficult coding, but again, the primary purpose of the way that I teach and the way that I learn is to understand the nuances, to understand what the hell is the computer doing from step to step to step. Now, that can get very tedious, but that's why computers are great for automation. Computers are very, very stupid, but they're also very powerful. They have no intelligence whatsoever until we tell it what to do. But it's very powerful in that it can do things way faster with much more complexity and more accuracy than any human being or any collection of human beings could ever do. And that's what we're capitalizing on. So it's important to understand how the computer is literally processing what the instructions that we're giving it. Because until you understand how it's going to jump around inside of your code, you're always going to be lost. And that's why it's not as simple as, all right, give me the code, let me write it, let me memorize it, now I know how to do this. If I get another example, I can put it in, because if that other example is slightly varied, if you're used to 3 arguments and now you have 7, and you don't understand how the computer was even functioning on the 3, you're screwed at the 7. And so that's why I think it's vitally important to get understanding of how the heck the computer is even thinking, so that you can maximize your education, which is going to then make you a better coder / programmer, and also appreciate the work that you do a heck of a lot more. All right, guys. Well, I hope you got some value out of this. I know I certainly always do going through it. It's fun as hell. And I will see you guys on the next video.